I wanted to build a robot, but didn't know where to get started. On top of that, sometimes it's difficult just to start designing and building from an idea all the way through to production. We're looking at is Isaac Sim and Isaac Sim 5.1, and I am using a version of Nemo Claw with MCP tools to make robots out of basically natural language. See on the bottom is me speaking with the scene and the scene being generated. As the scene is generated, errors that are encountered are looked up and fixed in real time. And once we fix these errors in real time, that information is now brought back to the corpus of information so that the next time that the agents go to create such a scene, they will have already encountered those errors and fixed them. So we can see here is a scene that was created by a combination of Nematron and Claude 3.7. And eventually we'll be using Gemini for robotics, ER 1.7 inside of this scene. And the newest released Isaac Groot, which I'm super excited about that as well. So that's a fully working scene. You can see the Kuka robot or the robots articulated. Moving on to how this actually works in slow motion. You can see I am typing here. And in my typing, you'll see that the scene will slowly show up. And we'll run through this quite quickly because this is about 20 minutes to create a scene from scratch. But you'll see that we go from no scene whatsoever all the way through to a fully working articulated scene with ROS2 topics and eventually even more things that we are used to, like Groot and OpenVLA and other tools. Even we'll bring in Isaac Lab as well and allow you to export these scenes. Today, you can export any scene you develop. This is completely open source. So in honor of being named an NVIDIA ambassador, I thought I would actually do something ambassador-like, which is give you something for free. And not just something, but I think there's something that it takes to go from zero simulation to full simulation for your robot. So bring in your robot, you'll see that the scene starts to develop on its own. So you're looking at the bottom right, you'll notice that the robot scene starts to, the conversation starts to happen about what needs to happen, what tools need to be called, how the model is thinking about developing the scene. You can also develop a scene from an image, as well as you can bring in custom robots as well. So what we're doing is looking at all the assets you have available. When you configure the environment, you will go and point at your asset library, as well as you point at your version of Isaac Sim and Isaac Lab if you have it. And then now you can see the scene is been built. A camera was brought in, actually several cameras were brought in. And since I said robot and I didn't say anything specific, they decided to create a NVIDIA Nova Carter. And Nova Carter already has joints, so it didn't have to do that. But it would have done that if you asked it to create articulations. It would have tried to create joints if joints were pretty reasonable. And if not, then you would have to bring in your robot with joints. But it does create the OmniGraph. Also, I'm traveling back from Modex, if any of you hear some noise in the background, so forget the noise. But you can see that we're using NemoClaw, we're using DGX Spark. And if there are some scene errors, I can tell it to look at the scene and fix it. So obviously when I hit play there, the robot was basically inside of the table, which made the table cause the robot to spin out of control. In this case, I just moved it. I mean, you don't have to do everything, or have the LLM do everything, and that'd be kind of wasting tokens, especially if you're using a cloud model. Using a local model like Quinn or Gemma or Nematron also work just fine. And you can connect to any OpenAI compatible model type. So you can, grab your own model from wherever you'd like to. If you want to use some of the other models that are out there, go ahead. And you see here, it's configuring itself. It's saying, it's looking at its errors, and it's saying, all right, if I have an error, this is how I'm going to solve it. If I have something that I'm trying to do, I'm going to go look at the internet to solve my problem. I'll also look back at my knowledge graph. I already have a knowledge graph and kind of rolling knowledge for what to do and what not to do, positive and negative tests. So you can see here the Omni graph is created itself. And if I go to the Omni graph first time around, you'll see that the ROS topics are somewhat their joint states, but I don't see the ones for my camera. So the very next thing I'm going to do is tell it, that I want to move the robot first. So I'm going to tell it to, show me how do I move this robot using just topics, and then from topics, then we'll bring in the cameras, and then finally we'll go into RViz. Since this is a long enough video, we'll stop it there. And in the next one, we'll go into Nav2 and ROS control, and some of the other things that you can do with spatial reasoning, like telling the robot to go to a specific place. Now you can see the robot's hopping a little bit. The wheels are a little bit janky. I didn't give it possibly all the right settings, and I can tell it to fix that if I want. But for the purposes of this video, we're just going to roll with it. You can see that there are various cameras, and I actually like the bounciness. That way it shows the camera's frames coming in live at about 30 frames per second. I'm sorry, 30 frames per, that's probably more than that. We'll take a look at how many frames are coming in for processment. Yeah, it's saying 60, 72 frames per second, 12, 11, not bad. But so the idea is that in one of the next ones, we'll go through and how do you connect this to navigation, but how do you connect that navigation to doing something reasoning capable? Like, let's say we have some items that we're trying to move into, or if we have a map that we want to generate, either a spatial map or a 2D map, should be able to do that. So one of the first steps to doing that is, first of all, starting to publish ROS topics and having those ROS topics published to a place that where you can use them. So being able to generate a ROS map, which is a kind of precursor to some of the other things you can do in basic two-dimensional ROS. And then we'll look at what happens in 3D spatial reasoning, where you don't even need to generate a map. I like to have a map because if the robot's going to operate in, say, a container, then you can do things like making sure the robot knows where it is. And if we have multiple types of sensors, like LiDAR, let's say we'll add some LiDAR to this and maybe the next one, and vision, especially depth. And we want to be able to map, align those two different cost maps that happen together, and make sure they, all the sensor fusion is as it's supposed to be. So you can see it still hasn't come up with all the topics. So I'm going to kind of say, hey, on with the camera topics. The first thing I'm going to do is I'm going to take a look at the camera topic myself, because I've done this before. So, I can already see a problem of a disconnect. And so that's when I'm going to tell it to how to solve its problem. So I'm going to say, hey, by the way, and so now it actually solved its problem. It looked and said, okay, I'm missing this. And so it can see the viewport window. So that's another interesting part of this, is that it can see its own viewport window in all of the windows that are built by Isaac Sim. Is it can see the console, it can see the content window, it can see the scene tree stage as well. So all of that, you can say, you can click on something and say, what about this, or do something, this, change the material here, and it'll actually go and do that. So here, to close out this video, I'm going to show the image topic. And so we're going to click on topic and pull in one of the images that we know. There it is. And so we can do that over and over and over again. And then the next one, first of all, please like and subscribe. We are definitely now that we are bootstrapping a whole company and open sourcing a bunch of things, including a few robots, I need all your help. So like and subscribe. Certainly, there'll be a Patreon coming up with files, active files for the robots that we're building. And I'd love for you all to, join in, support me, as I support others over the years. And yeah, let's get this robot thing on the road. Those of you that are not simulation experts, here you go. Now you don't even need to be a simulation expert. Give you MCP tools to do it all yourself. And thank you.